1/6, solving absolute value inequalities, and this is part 2 of 1/6. There are two types of absolute value equations. The first type is the absolute value of something is greater or greater than or equal to, and if you emphasize the word greater, it sounds like an or problem, which means either inequality needs to be true. The other type of inequality is the absolute value of something is less than or equal to. Again, if you emphasize that word less than, that "and" at the end kind of sounds like and therefore both would have to be true. Let's look at our first example. The absolute value of 3x minus 4 is less than 8. So since I emphasize my word less than, it's an and problem. Now you need to ask yourself, is my absolute value all by itself? Yes, it is. So we can go ahead and change the absolute value bars to parentheses and add the positive and negative. So remember, when you distribute your positive 1, it's not going to change anything. So I have 3x minus 4 is less than 8. Now when I distribute my negative, remember it's going to change both signs. So it makes it minus 3x plus 4 is less than 8. And I'm going to add my word and so that at the end I know what my graph should look like. So let's solve these both separately. So I'm going to start by adding 4 to both sides. So that gives me 3x is less than 12. And then divide both sides by 3. And x is less than 4. Bring down my word and. And then let's start with the inequality on the right-hand side. Subtract 4. So negative 3x is less than 4. Don't forget, when you divide by a negative number, it switches your inequality so that it becomes greater than. And then you can leave it as negative 4/3. Or if you like this as a decimal, you could write the decimal as negative 1.3 repeating. So let's draw this on a graph. So I have 0, positive 4. Since it is just less than, my circle is an open circle. Now negative 4/3 or negative 1.3 repeating, whichever way you want to write it over here, also is an open circle. And you know it's and, so you should shade in the middle. Press pause and solve the absolute value of 2x plus 2 minus 5 is less than 15, and then press play so you can check your answer. The first thing you want to check for is my absolute value bars all by itself, which I hope you notice it's not because of this minus 5 at the end. So we're going to add 5 to both sides of the inequality first. So that gives me the absolute value of 2x plus 2 is less than 20. Now I can go ahead and I can change it to parentheses and add my plus minus and distribute the positive. Remember, it doesn't do anything to what's inside the parentheses, you just rewrite it. And then remember, the negative is going to swap both signs, so it's going to become minus 2x minus 2 is less than 20. So let's start with our inequality on the left-hand side. Start by subtracting 2. So 2x is less than 18. And then you're going to divide both sides by 2. So x is less than 9. Now the inequality on the right-hand side, we're going to start by adding 2. So that gives me negative 2x is less than 22. And when you divide by a negative number, remember it switches your inequality. Now, at the very top, it was a less than problem, so this should be and. So let's draw ourselves a graph. I ran out of room, so I'm going to move it over here to the right-hand side. So I have 0, 9 gets an open circle because it's just less than. Negative 11 gets an open circle because it's just greater than. And then you shade in the middle because it's an and problem. Example 3. The absolute value of 5x plus 10 is greater than 15. So again, if you say greater like that, it reminds you that this is an or inequality. So your first question to yourself should be, are my absolute values by itself? Yes, which means I can change it to parentheses and add the plus and minus. So now write your two equations. 5x plus 10 is greater than 15, and then negative 5x minus 10, make sure you change both signs, is greater than 15. So now let's subtract 10 from both sides of the equation. So 5x is greater than 5. And then let's divide both sides by 5. And so x is greater than 1. And then remember, or, because it's greater. So now let's add 10. So negative 5x is greater than 25. And then when you divide by a negative number, it takes your inequality, it switches the way it's pointing. So now let's graph this. Remember, it's or. 1 gets an open circle. And then where is it greater than 1? Everywhere over here on the right-hand side. Negative 5, again an open circle because it's less than. Shade everything over here on the left, remember, because it's or. This is your last example. Press pause, solve for both of your variables, and then graph them and press play to make sure that you did it correctly. First question to yourself is your absolute value bars all by itself? I hope you notice that it's not because of the plus 3 and the multiplying by 2. So I'm going to start by subtracting 3. So that gives me 2 times the absolute value of x minus 3 is greater than or equal to 10. To get rid of your 2, you divide both sides by 2. Remember, you cannot distribute through absolute value bars. So that gives me the absolute value of x minus 3 is greater than 5. Change it to parentheses. Write your two equations. Remember to change both signs in the negative equation. Add 3. So x is greater than 8. I'm going to add my word or so I remember how the graph looks. Start by subtracting 3. So negative x is greater than or equal to 2. Then to get rid of that negative sign, you have to divide by negative 1, which causes your inequalities to switch the way that it's pointing. Now let's graph. 8 gets a colored in circle. Negative 2 gets a colored in circle. Remember, it's or, so shade accordingly, and that's your answer.